In the previous videos, we discussed pipelines in KubeRocketCI. We learned about their types, how they are triggered, and viewed their details. In all of those cases, we were satisfied with the pre-built pipelines and the tasks they perform. But what do we need to personalize them for specific needs? In this video, we will discuss the process of creating project-specific pipelines to meet business needs, review the recommended pipeline naming pattern, and walk through the complete process of creating one. The process of creating user-defined pipelines consists of 4 basic steps. First, we need to create a library codebase in the KubeRocketCI portal. This codebase will use the Helm pipeline framework. We will use the create from template strategy, so it will include all the pre-built pipelines by default. Secondly, we need to create new resources or modify existing ones. KubeRocketCI pipelines use 3 Tekton resources: a pipeline, a task, and a trigger template. Third, we will apply these resources to the platform and synchronize them using the Add-Ons repository. And lastly, we will verify that these newly added pipelines appeared in the portal and select them. When creating pipelines on your own, we should keep our resources organized. This is why we recommend following the concrete pattern when creating new pipelines. The recommended naming pattern starts from the Git server name. Don't confuse it with your Git provider name. Then you add the pipeline type, component type, and versioning type, separated by dashes. Following this pattern is not mandatory, but it greatly simplifies navigation between resources. Now, let's create a pipeline with project-specific logic. Navigate to the portal, select the Components section and click Create Component. Select Library, Create from Template. Specify the Git server, repository name, description, code language, and framework. In the Library Code Language field, select Helm, Pipeline, Helm. Next, Create, go to Library. Wait briefly for the codebase to be created. Navigate to the Branches tab. Click the Git button to open the newly created codebase in your version control system. This codebase contains templates for pipelines, tasks, and trigger templates, which can come in handy when creating your own resources. But keep in mind that Tekton might have other dependencies too. Now we need to clone this repository and proceed with creating our own pipelines. To save time, we will skip this process. Okay, great. We have downloaded the Tekton Custom Pipelines library. We created a pull request where we added a new task and modified the build and review pipelines by adding this task. A task is a set of commands to perform. A pipeline is basically a collection of tasks. We also deleted the remaining templates to avoid inadvertently disrupting the portal settings. However, to make these resources available in the platform, we also need to enable the KubeRocketCI pipelines component in the cluster Add-Ons. We created another pull request to the EDP cluster Add-Ons repository. Here, we enabled the KubeRocketCI pipelines component, specified a namespace, and provided the Git URL of our library with pipelines. Now, let's merge both of these changes. Let's merge the Add-Ons repository. Now, merge the custom resources. If you are wondering how to install and use the add-ons, please refer to our step-by-step instructions in the documentation. Open the product web page. In the Guides tab, select Operator Guide. In the navigation bar, select Installation, Install via Add-Ons. Here, you will find detailed instructions on how to install and manage the Add-Ons repository following the GitOps approach. Alternatively, Stay tuned for our next videos, where we will provide a demonstration on installing and managing add-ons. Perfect! Now we need to apply the changes in our add-ons application to the cluster. Open the Argo CD endpoint and check Applications. Find the add-ons application and open it. Here, synchronize the application to pull the pipelines from the add-ons repository. Open the KubeRocketCI pipelines component and synchronize it as well. Once the component is synchronized, navigate back to the portal and select the codebase where you want to set custom pipelines. Click the Actions button and select Edit. In the Review Pipeline field, select the modified pipeline. Inspect the pipeline structure to verify that it contains all the tasks you created. Next, select the modified Build pipeline. Click Apply. Now it is time to verify that pipelines work. We created a change to verify the pipeline function as expected. Let's create a pull request. Once the pull request is created, the review pipeline should start automatically. Navigate back to the portal to view its details. We will fast forward through the pipeline run. Now that the review pipeline has successfully passed, navigate back to the pull request and merge it. After merging the pull request, the build pipeline should start automatically. Navigate back to the portal to check it. As we can see, the build pipeline has started. We will fast forward the pipeline run. And that's it. Now we can see that everything works as expected. To sum up, customizing pipelines allows you to handle special use cases required by your business. We created personalized pipelines with their own tasks, added them to the platform using the add-ons repository, and applied them to our code bases. In future videos, we will personalize the environment deployment and cleanup logic by creating modified deploy and clean pipelines. That's it for today. Good luck!